The exercise we're about to do will help us with learning workbook pages 202 and 203. We're going to spend a little time talking about what happens to a number when you square it, and then specifically whether a squared number is bigger than or less than a particular provided value. Let me give you an idea of what we're talking about. On the board here I've drawn a number line that goes from -4 to 4. I've shown you various values of x on the number line. -4, -3, -2, -1, 0, 1, 2, 3, and 4. These are all values of the variable x. Now, here are two questions that we're going to try and answer. For what values of x will x squared be greater than 9? And for what values of x will x squared be less than 9? Okay, well, one of the ways that we can approach this is by saying to ourselves, well, these are all values of x down here. If we square each one of those numbers, then that would be giving us the value of x squared. Let's do a very simple example. If x is 0, then x squared would be 0 squared, which is 0. If x is 1, then x squared would be 1 squared, which is 1. If x is 2, square it and you get 4. 3 squared is 9. 4 squared is 16. Going in the other direction, we're going to get the same answers because a negative squared makes a positive. -1 times -1 is +1. -2 times -2 is +4. -3 times -3 is +9. -4 times -4 is +16. Now, there's one more value that I would like to throw in here, and that would be, what if x is 3.1? If x is 3.1, then we're going to get that x squared is equal to 9.61. And if x is -3.1, we're going to get that x squared is also still equal to 9.61. All right, so this is going to help us to solve this first question. For what values of x is x squared greater than 9? Remember, the numbers that we drew up here in green, these are the x squared numbers. So looking at the green numbers, where do we see numbers that are bigger than 9? Well, 9 is not bigger than 9, but the moment you step to the right of it, the numbers start to become bigger. So I would draw that as this kind of an interval. So I'd have a parenthesis at 3, and then I would have shading to the right. All of those numbers, all of those green numbers, are bigger than 9. But are they the only ones? No, over here we also have some numbers that are bigger than 9. The moment you step just the tiniest bit to the left of this green 9, then we have values that are bigger than 9. Now the question was, for what values of x is x squared greater than 9? So even though this is a visual representation of our answer, when we go to answer this question, we have to express it in terms of these x values. So looking at the x values, anything bigger than 3, so 3 comma infinity, or anything less than negative 3, which would be -infinity comma -3, this is the answer to the first question. You take this interval, and you take this interval, and you union them together. That's going to be the answer to the top question. So, for what values of x is x squared greater than 9? Anything bigger than 3, or less than -3. All right, now let's turn our attention to the second question, which is very similar. For what values of x is x squared less than 9? Well, you probably get the idea here that that would be these values in the middle. These are all of the values that are less than 9. We can shade this in on our number line here. Right? You can see them that they're less than 9. 0, 1, 4, those are all less than 9. But 9 itself has to be removed from the list because 9 is not less than 9. If you took just the tiniest step to the left of 3, say, I don't know, 2.5, when you square it, you get 6.25, which is less than 9. So the interval for this second question is going to be here shown in orange, which is parenthesis 3, comma 3, parenthesis. So the answer to the top question is this union of intervals. The answer to the second or the bottom question is this single interval here. This will be very important as we now turn our attention to our final topic of this section, domain.